Well, howdy, y'all. This is my hunting dog, Fitzgerald. He's ready to snatch something right now. You got it in your sights, buddy? Yeah, we go hunting together. We hunt. We're math hunters. He tackles and hunts down math problems, drags them back to me. Oh, he sees one. He's gonna get one. Right, Fitz? You see him, boy? You see him out there? You see them word problems? Anyway, he drags them back to me. I dissect them. I chunk them up so they're easier for us to digest. That's right. Okay, so are you done for this take? I think he may join us in a little bit. You ready? Go get him, Fitzy. Go get him. 1, 2, 3. Get him. Right. Good job. Good job. All right. He's a good little hunter. All right. Actually, don't tell him. He was our second choice in casting. Our big dog was who I was trying to get, Violet. We'll get her on a video before too long. She wasn't having it sitting on my lap looking at this computer screen. Well, Fitz is better behaved. We've had him a lot longer. All right, so we're going to do percent change today. Percent change is just when something changes and you want to measure or know, like, how much did it change? Did it change a lot, change a little? For example, my favorite kind of math is pizza math. Let's say someone gave you 2 slices of pizza, but then your friend, sister, brother, cousin, whatever, they gave 4 slices. Now, that's not going to make me too happy. I like pizza. But you could say right away, hey, why did you give him how much more? And some people are saying 2 slices more, but no, most of us would say twice as much as me. You can see the relationship. He got 2 times more. Or you might have said, hey, why did I only get half as much as him? Okay, so you can see that, all right? But it's not always that easy of a relationship that we can see and say. So let's take a quick look. We're gonna go to the share screen and I'll jot down a couple things here. Let's go to, I gotta go to annotate first. Go to text box and there we go, looks good. So let's just start this off here real quick. Jot down a couple quick things. So this is a review from earlier in the year, but if you don't remember it or it doesn't make sense, we got a great strategy for you. So hold your horses. Percent change. Something is changing and we can measure it. Now, generally, the past few years, I have just taught the way the textbooks they gave us told us to do it. And it was boring. I didn't have any little tips or strategy reminders. That just, sometimes teachers call it drill and kill. You just do it over and over and over and over until it makes sense and you memorize it, and then you get practice with word problems and understanding all the ins and outs of the concept, and you get it, okay? But if not, sometimes you need a little strategy to help. So this year, Fitz, you want to help me tell this one? Come here. Come here, buddy. Good boy. Come on, come up here. Come on. Come on. Jump up here. They need your help. They need your help. Okay. You need to see yourself. See yourself over there? All right, here we go. So generally, that's the way I've been teaching it from the textbook. But this year, our teachers at our school are pretty cool about sharing ideas when they see stuff. One of the teachers walked by, looked in my room, and walked in and said, oh, that's not how we do it. We teach no. And I was like, kind of started giggling like, okay, you just busted in my class and throwing this out in the middle of class. I don't know what the heck no is. I'm new here. What the heck are you talking about? And so it was pretty cool, right? Fitz, do you remember no? No. You're not in trouble. I'm just playing around. He doesn't like that word. That means he's in trouble. You're not in trouble yet. All right. You wanna go get? You wanna go get him? 1, 2, 3. Get him! All right. Okay. Good. Good boy. Good boy. All right. Yeah. The math problems are scared to death of him. He will tear him a new one. All right. So no. I was like, well, I don't get it. What the heck does no mean? So basically, there's a formula where you do the new amount or whatever happened. In this case, the new person, they got 4 slices, okay? But the old person or the original person had 2. So you take the new amount minus the original amount, and then you make a little fraction out of it, wrong key. And on the bottom of the fraction, we're gonna write original. Or some people say old amount, okay? I'm gonna write it that way. You can notice that it's either, you could say original amount or old amount, either or. But the trick of this, the reason it's called no, and I'm gonna switch colors here, is because the N to the O is no, and then the same N to the other O is no, okay? You don't put a second N down here, all right? So that's all you do. So let me finish this problem that we just did with the pizza. Click. So the new amount was 4 slices for your friend or cousin or whatever. The old amount is what you were given first, the original amount. You thought everybody was getting 2 slices, and all of a sudden, or 3, really. You thought you were getting 3 and your cousin or friend was getting 3, but they gave them 4. And you're like, what? Confused. So you take the new amount of 4 slices minus the original amount of 2 slices divided by the original amount of 2 slices. Okay, so there's my fraction. And I'm gonna, anytime we see fractions, I always say, always try to what, class? Simplify, okay? So 4 minus 2 is 2 over 2. That means 2 divided by 2. That simplifies to 1, okay? So we got a 1 here, all right? So what percent is 1? That's not 1%. Just a quick refresher. I'll do this down here. Let's say it was 1% means 1 over 100, okay? And if you divided 1 by 100, you get 0.01, all right? And then to change it to a percent, or to change a percent to a decimal, let me come over here and write 1%. If it was 1%, last little thing, and then we'll go back. Yellow, well, let's do blue, okay? One of the things we said in our earlier video is I see 2 dots, I move the decimal 2 spots. So then there's going to be a 0 there and a decimal there, okay? The decimal doesn't show up very well, okay? So that's how I got 1% equals 0.001, okay? This isn't 0.001, and there's no percent sign after it. So therefore, this 1 is the same thing as 100%. So if I want to change 1.0 to a percent, I got to move the decimal the other way. Instead of moving it 2 spots this way, I got to move it 2 spots this way. So 2 out of 2 is 100%. Okay, like if you made two shots, 2 baskets out of the 2 shots you took, that's 2 out of 2, that's 100%. Okay, so don't get confused on those. All right. So that's the basic formula. All you got to remember is no. No. Oh, I can't remember if I said this part. The reason she said, or how they get the kids to remember no goes with this, is if you do a whole bunch of percent change problems, they can get a little tricky, okay? They're not all easy. They're not all going to be 4 slices minus 2 over 2, you know, or 2 over 4 and all the easy ones. So if you do many of them, you'll get upset. And so students wouldn't want to do them. So anytime they say, hey, class, we're going to work on percent change, she said they would jokingly say back, no, we're not going to do it. No. And that reminds them of their strategy, if that helps you. Okay. So let's clear that and let's do some IXLs. We're going to, IXL is a great program if you haven't had the opportunity. It's got all kinds of topics and problems for all kinds of concepts for every grade level. So we are working in percents today. It's L9. I had put a star here to recommend it to my class. They're going to have a day and a half or 2 to do it. And if I click on it, the clicking on links while recording hasn't been working very well. So I went ahead and set up the next screen. So here's the first problem, okay? So I'm gonna go to my writing utensil and change to red, shows up a little better. And they're saying, what is the percent change from 76 to 19? So which came first? Which was the original? The 76. And if you want to just write them there, that's a good strategy too. And the new amount is 19. So did it go up or down? It went down. It went from a big number to a lower number. So it's going to be a decrease is going to be my answer. So I've already got a 50-50 chance because I got rid of 2 other options. It's not going to be an increase, okay? Secondly, I need to do the no. So the new amount is the 19. And the writing is still kind of weird for me on here. I apologize. And I'm going to subtract the original or old amount. And guys, it's kind of like, how do you subtract a bigger number from a smaller number? Well, that's just like you're going to owe somebody money, like you don't have enough. Like something costs $76, you have 19, you're still going to owe more money. So it's negative money out of your pocket. Or if you just remember, we did this in a previous episode, the different sign rule. I have a positive 19 and a 76 with a negative in front of it, or a minus, whatever you want to call it. But that goes directly to the 76. It's tied to it. So think of that as a negative number, positive 19, negative 76. You just take the bigger digit, subtract it. Hold on. My boy's digging down there. I don't think he realizes there's carpet with cement under it. There ain't no bones under there. Did you find something? Okay. That's funny. He's just digging like he's trying to check and see if this is ground. All right. Oh, you know what? I guess he doesn't like this carpet. He was like digging at the carpet to fluff it a little bit, and then he laid down on it. He's in his little like the Sphinx pose where the Sphinx has its paws out front and its head up in the air. Yeah. Oh. Okay. Let's finish this, guys. So new amount minus old amount divided by, it's going to be NO and O at the bottom. So the old amount, the original amount was 76. That's what I'm going to divide by. Okay. So the different sign rule says you take the bigger digit, subtract the smaller digit, and whichever digit has the bigger sign, that sign's going to win. Well, since there's more negatives than positives, I know my answer is going to be a negative something, okay? And that's why it's going to be a decrease over 76. Okay, so 76 minus 19, I'm going to have to borrow from the 7 and change this to a 6 because you can't subtract 9 from 6. I need to have this 1 over here. 16 minus 9 It's going to be a 7. And I borrowed 6 minus 1 is going to be a 5. So it's 57 out of 76. Now, the next thing you would have to do is try to simplify and or then divide. Now, as far as simplifying, what number could go into both? You know what? I think off the top of my head that perhaps 57 is a prime number. I know 51, 3 goes into, and 3 goes into 54. Oh, 3 does go into 57. But it doesn't go into 76. It goes in twice. 1 left over is 16. 3 goes into 18, but not 16. And 9 could, no, 9 couldn't. Anyway, so what you would do is if you can't see a way to simplify it, you would then have to divide. That's a numerator and a denominator, or a dividend on top, because it's going to get divided, dividend divided by the divisor on the bottom. The divisor is what's going to be doing the cutting. Okay, you're going to divide it up amongst the divisor for that many people. So anyway, so we got 57 divided by 76. Okay, now here's the one thing. This is a little bit of a number sense. When it's multiple choice, I don't want to sit here and do 57 divided by 76. I mean, I'm a math teacher. I love math and I love division too. But if I don't have to do it, I'm not going to waste your time. They're telling me it's either decreasing by 57% or 75%. So there's my 57. So is that my answer? No, that's 57%. Percent means per 100, 57 out of 100. This is 57 out of 76. So half of 76 would be 38. So 38 out of 76 would be 50%. This is way more than that. So it's got to be the 75%. So I'm going to go to mouse, select it. If it lets me, because it was cutting out a lot. Oh, all right, I got it right. Okay, so we're going to go on to the next one. Clear. And what is the percent of increase? And we'll go a little faster, guys. Okay, that was the first one. Let's go with green. If there's an increase from 400,000 to 500,000. Well, so right now, just to show a proportional relationship, guys, I can get rid of all these zeros as long as whatever you do to one side, you do to the other. So really they're saying something changed from 4 to 5. I'm finding a percent answer. So the proportional relationship is going to allow this to still have the same proportional relationship. You can try it if you want. But anyway, so the original amount is 4. And then it changed to 5. Okay. So, oops. That's the new amount. Undo, undo. I meant to put the in there. I wanted to notice which one is the new amount and which one is the original or old amount. So I'm going to have 5 minus the original amount of 4 and divided by the original amount, which is 4. Okay. 5 minus 4 is 1. And there's still a 4 on the bottom. So what is my answer with a percent sign? 25%. Make sure you say the percent sign because it tells me to use the percent sign. Outstanding. All right. Clear the deck. I'm just going to take you to the master's level. So even though this is the next level up, if you didn't notice what I'm doing, I skipped to the next level so I could show you one problem from each level, okay? You might see one of the ones I did, but you're gonna have to do like 8 to 12 problems usually, I think, to get to the 90s, okay? Okay, so this is the original amount. let's go with blue this time. Original amount, new amount. No again means you're going to have the no, and you're going to have a subtraction between them, and you're going to have an O down here. And one last time, it's called no because it's like N-O, N-O. Okay, you don't write a second N. New amount minus original amount divided by original amount. Okay, let's do the problem and be done here, Mr. Douglas. So I am, again, because both sides have 5 zeros on the end, I'm going to divide both sides by 100 thou. 100 thou, bling, bling. Okay, so then I really just have an 8 and a 9. The new amount, 9 minus 8 divided by 8. Okay, the original amount. All right, so I'm going to have 1 over 8. But they want me to write that as a percent. Now, 8 does not go into 100. I could do 1. Let's show you one of my little things I like to do. I like to do relationships. I could do 1 divided by 8, and it's going to be 0 something, and I'm going to have to, I'm going to have to borrow, okay? If you cannot, since they want a percent, guys, I'm trying to get to something over 100. And I tell my students, first thing you should do, this is a rate table or a rate relationship, okay? Can 8 go into 100 evenly? And if it did, then whatever you did to the bottom, you would do the top. So if 8 went into 100, whatever, it doesn't, then whatever you did times on the bottom, you do the top. So it doesn't. So I could either cross multiply and divide here, or some people might say, but you know what? I know 4 goes into 100, and 4 is 8 divided by 2. So if I divide 8 by 2, whatever you do to the bottom, and that's the little dots hard to make. It doesn't want to cooperate. Whatever you do the bottom, you got to do the top. So if I divide 1 by 2, well, sir, that's not going to be a whole number. I know, but just watch. So that's going to be 0.5. Now I can say, I'm going to switch to red to finish it, and we're done with this. Does 4 go into 100? Yeah, times 25. So 0.5 times 25 will give you my answer, okay? So you can just divide 25 in 2. 12 plus 12 is 24, okay? But I'm still missing 1. So half of 1 is going to be 0.5, okay? Now, does it tell me to round it or anything? This is a little tricky. It doesn't tell me to round it, so I'm going to try to enter my exact answer, 12.5%. 12.5%. Awesome. Okay, last one. For you to get to the challenge level in my class, if you get in the 90s, because it's so rigorous and there's so much work to do on most of these, if you get in the 90s, we usually reward you with 100%. Because the IXLs are very rigorous and have a lot of repetition of practice of the same types of problems, even after you get a concept. So all that practice is good for us. Okay, so what is the percent decrease? They're telling me it's negative already, so I'm not going to put a negative here. They're already telling me it's going down. What's the percent decrease here? Round your answer to the nearest 1/10 of a percent. Now, Let me see if I can write it a little quicker this way. Text box. So no is the new amount, which is 600. Oh, well, I did forget that I don't want to deal with all these zeros if I don't have to. You guys can. You're going to get the same exact answer as me. Okay, it's just more intimidating to look at it. It's just 9 to 6. Is it going to be the same proportional relationship? So back to my text box. We're going to have the new amount, 6, minus the original amount, 9. That is going to be over the old amount, 9, because it's no, and you use the same 6 for the end, no, okay? So now, minus 9 is 3. I gotta space it over. And I'm gonna have another fractione. And let's make that a little more centered. And I still got 9 on the bottom, okay? Now that simplifies. 3 goes into 3 one time. 3 goes into 9 3 times, okay? So I'm gonna have 1 over 3. Now that's not giving me a percent. Did I not put an equal sign here? I guess I did not. Okay, so now I need to divide 1 by 3. And if you've done fractions a little bit, you've memorized 1 over 3 comes out to 3 repeating forever. Let me just take a quick moment. So we say TIBO, the top number goes inside the division house, the bottom number goes outside. 3 does not go into 1, so I'm gonna have to borrow or show the 0 here. Oh, that's pretty. So now how many times does 3 go into 10? 3 times. So that would be minus 9er. 9! Okay, what's left? A 1. Okay, so we're gonna need to borrow again. Drop the 0, or not borrow, but go to the next place. So we drop the 0 down, drop it down, and how many times is it gonna go into 10? 3 times, which is 9. Oh boy, okay. So y'all know what's happening, right? You know what's up. So it's just gonna be 3 repeating forever. Now I need to really technically, to make my answer correct, get rid of that. Okay, so 0.3 repeating. They're asking me to round my answer to the nearest 1/10 of a percent. So as a percent, it's going to be 33.3 repeating, but I'm stopping there. We don't know how to put in a repeating symbol. So that's it, 33.3 to the nearest 10th. Great job. Okay, I got in the 90s, I'm getting 100. Hey guys, that's all there is to it. If I ask you to do percent change, you say, this ear, I can hear this ear. No, 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 all right? Hey Fitz, you wanna come say goodbye? Let's bring up, we got some different colors. I was gonna do some samples of my own, but then I just decided to do the Excels. Fitzy, come here, say goodbye, come here. Come here, buddy, come on. Got a treat? You want a treat? You want a treat? I'll go get you a treat. Oh, he's all comfortable. It's been a long day in the studio with Mr. Douglas. Y'all take care now. I'm gonna go to stop share and we're out. God bless you and your family. Stay safe.